One of the classical instruments used for finding the resistance of an unknown resistor is the Wheatstone bridge. It consists of 4 branches with resistances P, Q, R, and S. The galvanometer, G, is connected in between the terminal B and terminal D of the instrument. The flow of current from one potential divider to the other is monitored with the help of the galvanometer. Assume that the 2 voltage dividers have exactly the equal ratio, say P by Q equals S by R. Under this condition, terminals B and D will be at the same potential. The Wheatstone bridge is then said to be in balanced condition. There is no flow of current through the galvanometer in both directions. Assume that the resistance value of any one resistor out of these 4 resistors changes even a little bit. The bridge will then become unbalanced and some current will flow through the galvanometer. Now, P divided by Q is not equal to S divided by R. You will now see how the bridge works, in measurement of an unknown resistance. The values of P and Q are precisely known, but they do not need to be identical. The resistor S is a variable one. Connect the resistance Rx as shown, whose value has yet to be found out. Switch on the power supply by placing the key K1. Press the push button number 1. If the galvanometer shows large deflection, it shows unbalance in resistances. Adjust the variable resistance, S, to carry out course balancing till the galvanometer reads 0. Now, press push button 1 and push button 2 simultaneously to carry out fine balancing by further adjusting the variable resistance, S. Try adjusting the rheostat, S, in various ranges until the galvanometer, G, reads 0 current. At this point, Rx equals S times Q divided by P. From the above formula, the value of resistance of the unknown resistor, Rx, can be found out. The Wheatstone bridge is one of the commonly used transducers in most control instruments and systems. Assume that the bridge is used in temperature measurement. Rx is placed in the spot whose temperature has to be measured. Rx may vary when the spot temperature varies. Then, the ratio becomes upset, causing current flow in the central wire, that is, through the galvanometer. This current can be calibrated in terms of temperature that's being measured. For example, let us say that the bridge is balanced at ambient temperature 30 degrees with Rx equal to 6 ohms. No current flows through the galvanometer, that is the temperature meter. As the temperature in Rx increases, the resistance increases, and a current flows through the galvanometer, that is the temperature meter. The value of this current is used to indicate the temperature at the resistor Rx.